This is part 3 of the 5-part series on the net ionic equation. In this video, we're going to write total and net ionic equation where only the reactants are given and nothing else. If you're new to writing net ionic equations, I recommend you start with the first 2 videos in this series. Let's take a look at the question. We're given the reactants, and that's about it. I consider this a rather difficult question since we're not given the products and the physical states. So since that's the case, the first thing we need to do is to predict the products. Before we can do that, we need to first know what type of reaction these reactants will undergo. So generally, there are 3 types of reactions involving net ionic equations. The first being a single replacement reaction where A and B will swap place. That's why it's called a single replacement. The second type is a double replacement where AB and CD will both swap partners with each other. Since 2 terms are swapped, that's why it's called a double replacement reaction. The third is neutralization, where acid and base reacts to form salt Ba and water H2O. So let's take a look at our question. We have Mg and CuNO3, and that looks like a A plus BC reactant. So that means we're going to work with a single replacement reaction. So A is actually Mg metal, and B is Cu plus. C is NO3 minus. If you need a refresher on how to identify the ions in ionic compound, I'm going to link the video here. So now that we've identified our ABCs, let's go ahead and figure out if the reaction will proceed or not. Because this is a redox, we need to first figure out if this reaction will proceed. If it doesn't proceed, there's no point in continuing. So to do that, we need the reactivity series. In order for the reaction to occur, the metal, the free metal, has to be more reactive than the cation metal. So that means Mg has to be more reactive than Cu. So let's check our reactivity series. Mg is here and Cu is here. So since Mg is higher than Cu, Mg is more reactive. So that means the reaction will take place. So in that case, let's go ahead and swap A and B. So when we combine, our AC is actually going to be MgNO3 2. So we want to make sure that we pay attention to the charges of the ions, and when they form the ionic compound, make sure the formula is correct. Mistakes can be done by just writing the formula for AC as MgNO3. So don't do that. Now that we've figured out the products, it's time to move on to the second step, which is identify the physical states. So we need the solubility rules for this. I'll link a video if you need a refresher. Looks like we have solid for magnesium and copper, and aqueous for copper nitrate and magnesium nitrate. Moving on to step 3. We need to make sure that the equation is balanced. So we need to place a 2 in front of CuNO3 and a 2 in front of Cu. And that will make sure that both our atom counts on the left and on the right are the same. Step 4. We need to ionize the aqueous terms. That means we need to break the terms that have aqueous states into ions. Now it's important to note that we only do that for aqueous terms. We don't do that for solid, liquid, or gas. So let's start with the first term, which is Mg. Mg is solid, so that means we're just going to leave it be. We'll just write Mg. And moving on to the second term, CuNO3, that's an aqueous. So they will split to give us 2 Cu plus and 2 NO3. The reason we have the 2 there is because there is a 2 in front of CuNO3. So when they break into ions, we have 2 of each. Since Cu is solid, so we just write 2 Cu. And last but not least, MgNO3 2. So that's an aqueous. It will break to give us Mg2 plus and NO3. And again, don't forget that 2 in front because there's a 2 here. That means we need to make sure that there's a 2 NO3 minus ion. At this point, we have written the total ionic equation. So we're done with step 4, and we're going to move on to the final step, which is cancel the spectator ions. So spectator ions are ions that exist on both sides of the equation. In this case, we have 2 NO3 on both sides of the equation. So we're going to cancel them out. And now we have to rewrite the equation, and that will give us solid Mg plus 2 Cu plus Aq, giving us 2 Cu solid plus Mg2 plus aqueous. That's the net ionic equation. Let's double check our work to make sure that we wrote the correct net ionic equation. So the number of atoms and charges must be the same on both sides. So let's check real quick. we have 1 mg on both sides, 2 Cus. As for the charge, we have a total of +2 on the left-hand side and +2 on the right-hand side. So that means both the atoms and the charges are equal on both sides. That means we did it. So there we have it. We managed to write the total and net ionic equation in 5 steps. To recap, when the question only gives you the reactants, we need to first predict the products after figuring out what type of reaction is involved. For single replacement reaction, we need to check the reactivity series to make sure that the reaction will happen. Since the physical states are not given, we need to use the solubility rules to determine the physical states for every term. And then we balance the whole equation. And then after that, we split the aqueous terms. We leave the solid, liquid, and gas terms alone, and that will give us the total ionic equation. And then after that, we cancel out the spectator ions and rewrite it, and that will give us the net ionic equation. If you are looking to practice on writing net ionic equation for other types of reactions, do watch out for part 4 and part 5 of this series. I hope the video was helpful somehow. Do subscribe, and thanks for watching.